This is a video run-through of Ubuntu 22.04 LTS Jammy Jellyfish running on Libre computer boards. We're going to be running through common desktop setup, as well as common utilities such as browsers, setting up GPIOs, setting up device tree overlays, as well as running 3D graphics on the system. The image we are demonstrating today is the 22.04.1 release desktop image powered by Linux 5.19 and Gnome. It is available on our distro download site at distro.libre.computer/ci. After you have downloaded the image, you need to decompress the image and then flash it to a microSD card. We recommend using a bit-for-bit imaging utility such as Win32 Disk Imager for Windows, Apple Disk Utility for macOS, or Gnome Disks for Linux to write the raw image to the microSD card. Please avoid using Etcher and other tools that perform skips, as they can cause the image to not boot. Use a high-quality microSD card from Samsung or SanDisk for best performance. MicroSD card quality is directly correlated with performance. Slow microSD cards will take longer to set up and may cause the system to freeze if data cannot be read or written to disk fast enough. The Ubuntu image is customized to check for microSD data errors and compress the data before writing it to disk to optimize write bandwidth. If there is disk corruption due to microSD card issues, you will see a message in the system console by typing in dmessage, DMSEG. To optimize performance, our images utilize Gnome, Wayland, and Weston compositors for a tear-free experience. X11 compatibility is provided by Wayland. Our Ubuntu images comes in two flavors, server and desktop. This demonstration is of the desktop variant, where an installer runs on first start. You will be prompted to select your language, username, and other settings to configure your system before starting. For the server images, the default username and password is Ubuntu and Ubuntu, but please wait 5 minutes after startup for the cloud init to initialize the initial users. After you have set up your system and user settings, the system will attempt to do an upgrade from the internet. Please cancel this to get to the desktop as soon as possible. By default, the desktop image starts in Gnome Desktop Compositor. Please install Chromium first, as it supports Wayland slightly better than Mozilla Firefox. Use eatmydata to disable fsyncs to enable faster write performance when installing packages. To install a 3D OpenGL ES2 demo running on Wayland, run apt install glmark2 ES2 Wayland. Additionally, please install Build Essentials for the Make application in order to compile the device tree overlays for a later demo. We have designed a brand new wiring tool for GPIO lookups, GPIO translation from Broadcom or Raspberry Pi numbers, as well as lookups for both sysfs and GPIO-D numbers. Alternative functions for GPIO pins are also listed. We're going to be doing the demo shortly. Please first clone the GitHub repository on this website. Device tree overlays are also supported by the wiring tool. The wiring tool includes common device tree overlays for SPI, I2C, UART, PWM, SDIO, and more. You can write your own device tree overlay and then compile it using make. So please run make before you attempt to enable any device tree overlays. The utility for device tree overlays is called LDTO, standing for Libre Computer Device Tree Overlays. Our device tree overlays can be applied at runtime rather than at boot time. Runtime device tree overlays can be enabled and disabled at will to reconfigure the system for different purposes. Some device tree overlays cannot be disabled, or they will cause memory leaks due to the way the kernel is. Within our wiring library, we include the LGPIO utility for quickly looking up GPIO numbers. GPIO numbers can be in the form of the sysfs number, which is the legacy method, as well as the GPIOD numbers, which is based on the chip and the line number. Alternatively, it can also give the alternate function of the pin for alternate functions such as I2C, SPI, etc., etc. There are two ways to look up the GPIO number. First, if you type in LGPIO info and then the pin number based on the 40-pin header, you will get the sysfs and GPIOD numbers for the first pin. To look it up based on the BCM numbers used in Raspberry Pi, please type in LGPIO, BCM, and then the pin number on the Raspberry Pi. It will return the proper GPIO line number and sysfs numbers. For a visual representation of our GPIO headers, please head to our website and go to the product page. We offer a visual map of all GPIOs and additional pins for your reference. The sysfs interface for accessing GPIOs is a legacy interface. In the future, this interface will be disabled by Linux and will not be accessible. We highly recommend that you move off this interface for the future. For legacy reasons, we enable this feature in the Linux kernel in our images, but this is not guaranteed to be present. The modern method of accessing and controlling Linux GPIO interface through the user space is via the libgpiod library. This library provides more advanced control of the GPIO features such as biases, drives, and modes, along with reading and setting the GPIO lines. You can read GPIOs via GPIO get and set GPIOs via GPIO set from the GPIOD package. To install, type in apt get install GPIOD. As a participant in the open source community, we identified major roadblocks for end users. We work with the community to bring Mali Adgar support into Mesa for fully open source graphics. Previously, 3D graphics was only available through the closed source Mali binaries. Now we have an entirely open source stack for Linux video and 3D graphics. This enables our products to support 3D acceleration in Google's Chrome projects, as well as video acceleration once Google implements the mainline v4L2 interface. Low-power ARM SBCs feature very capable hardware video decoders, usually provided through proprietary APIs. We worked with Bay Libre and other consultancies to bring these features into upstream Linux, and now there is a standard v4L2 interface for controlling video decoding. There's still a lot of work to do on this front, but basic H.264, H.265, and VP9 support have been implemented. This is a very big accomplishment for standardizing video support across the ARM Linux world.
Wake up. Open your eyes. This is Sony 4K. Beyond 4 times the resolution of 1920 by 1080, it will take you to another world. It is a world seemingly familiar, yet filled with fresh revelations. A young planet called Earth.
We covered a lot of new developments in the ARM SVC world. To facilitate dialogue, we are introducing hub.libre.computer. This forum provides user access to advanced knowledge of our engineering team. It also provides us with feedback so we know how we can improve things for you in the future. We'd love to hear from you. This concludes the overview of ARM Linux innovations on Libre computer boards running on Ubuntu 22.04. For additional information, please visit our Hub website at hub.libre.computer. We will be demoing Weston, a lightweight and powerful reference Wayland compositor from now. This is for advanced users seeking to extract the most performance from our boards and features very few controls. It enhances the performance of software and hardware video decoding and 3D graphics. It is designed for Linux minimalists and customers in industrial, commercial, and automotive sectors.